Hello, and welcome to this lesson on electrolysis. In today's lesson, we will aim to have a general overview of electrolysis. We'll start by defining what electrolysis is and its significance in the field of chemistry. Then, we'll examine how electrolysis works by discussing the roles of the anode and cathode. Finally, we'll explore practical applications and examples of electrolysis in real life. So far, we've discussed the reactivity series and redox reactions. You've learned that the reactivity series helps us predict how different metals will react, while redox reactions involve the transfer of electrons between substances. In this lesson, we will examine a real-world process that utilizes those principles, highlighting the integral role of chemistry in daily life. Electrolysis is a technique that uses direct current, DC electricity, to decompose ion containing solutions known as electrolytes into their constituent ions. Electrolytes are defined as liquids or solutions that can conduct electricity. These electrolytes are often ionic compounds or molten salts that conduct electricity thanks to the movement of ions. For example, sodium chloride is a strong electrolyte. In an electrolysis setup, we use electrodes to make electrical contact with the electrolyte. These electrodes are typically made of conductive materials, such as metals or graphite. Here are the main roles of the two types of electrodes. The anode, this is the positive electrode where oxidation occurs. Anions, which are negatively charged ions, migrate to the anode. At the anode, these anions onslows electrons and are oxidized. For example, in the electrolysis of molten sodium chloride, chloride ions, Cl-, migrate to the anode and lose electrons to form chlorine gas, Cl2. The cathode, this is the negative electrode where reduction occurs. Cations, which are positively charged ions, migrate to the cathode. At the cathode, these cations gain electrons and are reduced. In the same example of molten sodium chloride, sodium ions, Na+, migrate to the cathode and gain electrons to form sodium metal, Na. One way to remember that cathodes are negative and anodes are positive is to use a mnemonic, such as panic. Positive is anode, negative is cathode. Overall, the electrons flow from the anode to the cathode, forming a closed circuit. This apparatus is referred to as an electrolytic cell. Typically, we use graphite or platinum electrodes for electrolysis. Can you guess why? It's because graphite and platinum are unreactive or inert, and so they do not take part in the reaction occurring to the electrolyte. Electrolysis has vast practical applications that impact our daily lives. It is used in the purification of metals, the production of chlorine and sodium hydroxide from brine, and in electroplating, where a thin layer of a desired metal is coated onto another material. By exploring electrolysis, we deepen our comprehension of how electrical energy can drive chemical changes, enabling advancements in various fields such as energy storage, material science, environmental technology, and more. In today's lesson, we delved into electrolysis, which involves using electrical energy to drive chemical reactions. We began by defining electrolysis as the decomposition of electrolytes into their constituent ions through direct current electricity. We broke down the components of an electrolytic cell setup, understanding the roles of the anode and the cathode. This process is crucial in various applications, such as gas production and metal extraction, which we will delve deeper into in an upcoming lesson.